Hello guys, welcome you all for this session on AML. It's going to be an end-to-end session where we're going to learn everything in order to become a successful data scientist. So I will say we are like we have completed nearly 20 plus sessions, 25 plus sessions. So we are happy. We are learning every day. I hope you guys are very happy and you guys are started learning and doing assignments whichever we have given previously. And you guys till this stage, I hope like everyone has less watched all the previous video. If you guys have not watched previous video, please make sure that you guys all watched all the previous video. So today it's gonna be a continuation of previous session where we have introduced some of the most important libraries that are available in R for data science. So yeah, we will be continuing that. So again, I'm just mentioning, please make sure that you guys watched all the previous videos so that you can have a better understanding of what we are doing. Okay. So yeah, we will continue the things. So we are just going through the libraries which are present in R, which will be very helpful for data science. Today we're going to see statistical modeling with the LM and GLM. Let's see LM. So it's a function. Okay. So it is a linear regression model. Model linear relationship between variables predicts the dependent variable based on the independent variable. So we are having linear regression, right? So from SQL we will be importing from linear model. We will be importing linear regression in Python. Okay, so SQL. Whereas here there is a function called as LM, which will import the linear regression model. Then we are having GLM. It's a generalized linear model, so extended linear regression to handle the different types of data, such as binary, categorical, or count data using a different link function. So considered in a scratch manner. A GLM is the extended version of a linear model. So where we will be creating, so yeah, this is the plot that we are having, right? We will just plot all the data points and we will be fitting a line. Okay. What this will do means visually, it will just whenever we train, the line will keep on moving here and there, and it will try to fit to the data proper, not like proper, I will not say proper, it is like a optimal. It will try to fit the line which is optimal for our data set. It will just move here and there and it will fit the data set. Okay, see this data points or the dots or the data set, and this line is a fitting line, okay, which is done by this LM or GLM, anything. Okay, it will try to fit the things. Okay, so I hope like I have explained in a easier manner. So yeah, this is what about this library that is doing statistical modeling using R, which is very helpful for us. Yes, sir, over to you.
Yes, guys. Statistical modeling with LM and GLM model. Okay. So LM is a linear regression model. Model linear relationship between variable, predicting a dependent variable based on independent variable. That's what it is. It is the same linear regression concept, but used in our LM and GLM. They have their names. Okay. Then GLM is generalized linear models. So extends linear regression to handle different kind of data such as binary, categorical, count data using different link functions. So this is all. Keep it simple. Huh? Less is more, guys. So when you keep things simple, lesser information in your mind, and you apply them properly, that is the best thing. Okay. So we have to do dimensionality reduction in our mind also. Huh? So simply, linear regression here, it is just used as LM, and the concept is same, whatever is the linear regression model. So general linear models are extended linear regression to handle different kind of data such as binary, categorical, count, and data use different kind of link functions. That is GLM. That's it. It's very simple. Let's move to the others section.
Yeah, sure, sir. So moving on. Okay, machine learning with cart. Okay, we have mentioned right in sklearn is present in Python, which do all kind of which has all kind of machine learning models in there. So now we're gonna see cart, which is our machine learning libraries. So R's library for doing machine learning. Okay, we'll see in that manner. So cart. So data pre-processing. So prepare data for machine learning by handling missing values scaling features and then transforming data as needed. So that's the first thing. That is data preparation. I think we have done nearly 15 plus sessions. Okay, 10 to 15 plus sessions on data pre-processing itself. Model selection. Choose the appropriate machine learning algorithm based on the data and the problem you are trying to solve. Yeah, based on the data set that we are having, on what problem statement we are getting, based on that we need to select the model, because like there are n number of models are there, man. So like I'm just not exaggerating, there are n number of models which are available out. Okay, you just go for the documentation of cart, you can see that much model. And also if you are going for Python, just go look into the sklearn library, there will be n number of models. So based on your need, based on your application, you need to choose what model you need to use. Okay, then model training. Once you chosen the model, train the chosen model on the labeled data or unlabeled data based on your incentive. Allow the model to learn patterns and relationship from the data, so that you can predict the unseen data, right? So try to make the model run, so it will helps us to predict the unknown data. Okay, next, model evaluation. Access the performance of the trained model on the holdout set, evaluating its accuracy and generalizing ability. This holdout set, if you guys have watched previous videos, you can able to understand this, because like that is a model evaluation technique, right? We and sir has discussed k-fold cross validation. So that is what this holdout set means. We will mention how many sets should be training and how many sets should be hold for the testing. Okay, like that we need to go for model evaluation. So this is what the flow. Mm. So yeah, that's what are about machine learning that is available in R through the library called as Spark. Yeah, sir. Over to you.
So machine learning with CRET, CART. So we do data pre-processing, guys, in this, and preparing data for machine learning by handling missing values, scaling features, and transforming data as needed. That is what we have to do. Step two is model selection, choosing the appropriate machine learning algorithm based on data characteristics, and problem you're trying to solve, problem statement. These are very important. So you have to select model according to that. If it is categorical, it is categorical. You will choose right model, okay? And if it is not categorical, you have to choose according to the model. Model training, train the chosen model on the labeled data set, allowing model to train patterns and relationships from the data. So when we are doing model training, so in unsupervised learning, it will data will not be labeled, huh? So in supervised learning, data will be labeled. So you have to see that when you are training the model according to that. Model evaluation, assessing the performance of the trained model on the hand out data set, evaluating the accuracy and generalization ability. So your model should always generalize well. So plus minus both. It both like bell curve. It should be able to generalize both sides. So then and only you will get an insights. Otherwise, it would be biased. It would be overfit or underfit. So performance will not be according to that. So that is why this is very important. All these steps are very crucial. So from data collection, from the beginning, from data collection, from the beginning, I think first of all, problem statement should be very clearly defined. According to that, you are going to collect data. Then source should be right, ethical, privacy, all the considerations. And then you need to do pre-processing, EDA, and other model selection, model training, model evaluation. So this is life cycle for the data pipeline, whatever data or objective function you have as per the problem statement. So let's move to the other section.
Yeah, sure, sir. So moving on. Okay, actually we are having one more library, type text. Okay, so in order to do any kind of text related problems, we can go for type text. Okay, so first thing first, tokenization. Okay, break down the text into individual words or token, preparing the data for analysis. Okay, guys, till now we have just discussed about like I think numerical data, right? So pre-processing related to numeric data. But when it comes to text data, we will be having a paragraph of words, right? But like to machines to understand, we need to convert to a form of machine can understand. Okay, so we are having a text. Consider we are having a line like I'm going to temple. Okay, what we need to convert means we need to first of all tokenize everything. I am going to temple. I hope you guys can understand. We are having a sentence. We're gonna convert into words. Now we are having words. Okay, that is what called as tokenization. Whether the words will be understandable by machine, no, right? We need to convert into zeros and ones. For that, we will be using a technique called as vectorization. Okay, vectors are creating embodies. Okay, we will map each and every words to some kind of or some form of numbers. That's it. That is what vectorization or embodies. Now the machine can understand, right? Now it is zeros and ones, so the machine can easily understand. So that is what the first thing that we need to do as a processing in text. Okay, okay, what is the next? We are having sentiment analysis. Determine the emotion of tone of text, classifying it to positive, negative, or neutral using lexicon-based methods or machine learning models. Yeah, once we have a text, we can easily understand, right? So based once we are having embeddings, we will pass the embeddings to the model. That is numbers, guys. Text which are converted to numbers, we pass to the model. Now the model can do whatever we need based on the tuning. Okay, what kind of model we use. Okay, I'm saying a statement. Let's see if you guys can understand. I'm amazed to work on this kind of data science project. Okay, what is the emotion of it? Positive, right? Because like we have said the word called as amazed. Okay, so that's the thing. Okay, so like that we will be having some key terms. Based on that, the missions or model will also give what kind of sentiment we are just facing based on the tone and the texture of the text. It will create whether it is a positive, negative, or neutral. Okay. Next, topic modeling. I will say it is now also it is very popular. Discover underlying topics or themes within the collection of documents, identifying patterns and recurring concepts. Okay. So based on the documents that we have collected, we will create a embeddings, and from that we will create a underlying topics or themes which is based on this entire document. So this is also like growing field guys. Okay. So these are the things that we can do by using this type text. Yes, sir, over to you.
Yeah. So text analysis with tidy text. Okay. So TIDY text. This is a library in R, guys. So tokenization, we break down text into individual words. Why? Because then we'll have specific meaning of that particular word, right? So it, see, if you, I'll give you an ontological understanding that if you understand whatever knowledge you have, PhD or whatever you have done, you know the meaning of certain words, and you know how to make structure sentences, and you're aware about them, you clear all exams based on that. Same way, computers and models learn by individual words. You have to do tokenization so that the model learns word by word and even meta level word meaning, because word is one meaning. So but when you go for NLP, guys, we human beings don't use words the way computers use. We will be talking something else, some other correlation will be there, and other person will understand, but computers don't understand that way. So you have to give very specific meaning and permutation combinations of that. So here I'm going very objectively, I'm making it clear that why words, because words will have meaning and model will learn from that. Or tokens, preparing data for analysis. Sentiment analysis, determining the emotional tone of text. That is very important. Sentiment analysis, customer would be saying in a different sarcastic way. Model will not understand. Model understands straightforward, right? So you need to make it that way. The sentiment analysis should happen that way so that model understands the actual meaning. Classification of positive, negative, neutral using lexicons based on methods and machine learning models. So I'm just giving meta level understanding. Otherwise, it determines the emotional tone of the text, classifies positive, negative, neutral, and using lexicon based on the machine learning model. Okay, this is what does sentiment analysis. I'm doing a deeper level. I'm giving explanation so that you understand the other aspects also, which might impact your performance of the model. So, topic modeling discovers underlying topic themes within the collection of document, identifying patterns, recurring concepts. So this is what helps in topic modeling. So let's move to the others.
Yeah, sure, sir. Next time. Okay. So yeah, conclusion and resources. So our libraries offer a wide range of tools for data science. Okay, I hope now you guys can we have justified by using different libraries, empowering you to explore data, building insightful visualization, and create powerful models. Okay, as you continue your journey, explore the vast array of R libraries available, discover their functionalities, and leverage their power to solve complex problems in the field of data science. Okay, what they are telling. Okay, the simple thing. Okay, we have given you base. Okay, just see these are the libraries that are available in R. Go and explore. Okay, there are n number of libraries are available that you can use in R to make the things very easier when it is a data science problem. Okay, so yeah, that's the thing, guys. So yes, sir, over to you.
Yes, so conclusion and resources, guys. All libraries are very robust. They are very powerful for data science, empowering each one of us for exploring data, building insights, visualization, creating powerful models. It can be used for continuous journey exploring vast areas of R. R has a very good community which will help us to solve the problems and become better data scientists. Libraries are there discovering functionalities, leveraging their power, solving complex problems in the field of data science. So R is very if you want to become a data scientist, great data scientist, I'll say number one, 1% data scientist. You should be knowing end-to-end 360-degree R. And if you want to become a deep learning engineer or AI engineer or data engineer or any engineer in AI ML, any kind of specialist, guys, data science and R is a crucial. So sometimes you will not have data scientists in your team. So what will you do? You have to do it yourself. And as a AI researcher, you need to know end to end about AI ML, AI scientist or a data scientist. Even you as a data scientist, you will not have a AI engineer or deep learning engineer. You need to know other aspects also. Systems thinking is very crucial, guys. So understand these tools. They are powerful. Their libraries, their functionality, documentation. Go and study all these things deeply. Um, Watch the sessions 5 to 10 times. Write to us, give us feedback how we can improve and we can make it more and more engaging and valuable content for you guys. So also press the bell icon so that you will get notification for each session. Also, um, um, subscribe to our channels and do all the assignments, do absorb the information, digest the information, apply, do all the assignments so that you will apply all these concepts and you will become world's best data scientist, AI engineer, AI researcher, or scientist in AI ML. Thank you so much. See you in the other session.
Yeah, guys, just look into all the videos that we have done. So we have completed today the libraries, essential libraries which are available in R for data science. So yeah, guys, we will meet in the next session. Before that, if you guys have any doubt, just ping in the comments. We are here to help you. We will take up and we will just discuss and we will just clear your doubts. And before that, if you guys doesn't subscribe to our channel, please subscribe to our channel, because like then only you doesn't miss any videos. So yeah, guys, until then, like we will meet in the next session. Until then, bye. Take care. We will all meet in the next session. Yeah, guys. Bye.